Let's see how we're going to write an explicit formula for a geometric sequence. Geometric sequence is basically a list of numbers that is either increasing or decreasing by a multiplying factor. This geometric sequence is increasing by a rate of times 3. So each time you want to find the next number, just multiplying it by 3 to get the next one. Now, to get the fifth term, 81, we had to multiply the number 1 with the number 3 4 times. And that can take a long time if we want to find the 20th term. So what we do is we start with the first term times the number 3 raised to a power of 4. And you get the number 81. The reason is 3 times 3 times 3 times 3 is the same thing as 3 raised to the exponent power 4. As you can see, we only had to raise it to the 4th power when we want to find the 5th term, because we already have the first term. So we only have to multiply it 4 times, which is raised to the 4th term, which is 1 less than the term that we want. So the explicit formula for this would be, if you want to find any nth term, like the 100th term or the 1012th term, to start with the term number 1, multiply it by 3, raise it to the power n minus 1, which is 1 less than the term that you want. Just like when we wanted the 5th term, we raise it to the power 4, which is 1 less. This geometric sequence is fluctuating from a negative number to positive and negative to positive. That means it's being multiplied by a negative number. And in this case, it's being multiplied by negative 3. So each time we're multiplying a negative 3, it causes the sequence to go back and forth between positive number and negative number. So right now we have 5 terms. If I want to find the 6th term, all I need to do is start with the first term, negative 1, and then I multiply it 1, 2, 3, 4, 5. I multiply negative 3 5 times. Now, when you multiply the same number 5 times, it's the same thing as taking that number, raising it to a power of 5. That means the same thing as multiplying negative 3 by itself 5 times. So to find the 6th term, I would start with negative 1, and I multiply negative 3 5 times, and I would get the answer. And the answer in this case would be a positive number, 243. It's a positive number. Alright, so let's recap that. To find the next term, I just start with the first term. I use the common factors being multiplied by, raise it to the 5th term, which is 1 less than the term I'm looking for. So to write the explicit formula for this, you start with the next term equals the first term, which is negative 1, times the common factor, which is negative 3, and you multiply that n minus 1 times. This is 1 less time than the term that you're looking for. Just like when we want to find the 6th term, we would multiply the factor 1 less time. 1 less than 6 is 5. This geometric sequence is decreasing. It's getting smaller because it's being multiplied by a factor of 1/2. 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8, and so on. So the common factor is 1/2. So this is the first term. We have 5 terms already. If we want to find the 6th term, we would have to multiply it by 1/2 one more time to get the 6th term. If you look at the 6th term, we actually only had to multiply 1/2, 1, 2, 3, 4, 5 times, because we already have the first term. So when you multiply 1/2 5 times, it's the same thing as taking 1/2, raising it to the 5th power. Okay, when you multiply it by the first term, you get the 6th term. So to write the explicit formula for this geometric sequence for any nth term at all, the next term of any location, like the 100th term or the 200th term, that's called the nth term. All you do is start with the first term, which is 1, multiply it by the common factor n minus 1 times. So the exponent would be n minus 1. Just like in the 6th term, we multiply it 5 times. So the exponent is 5, 1 less than 6. And that's it.